Now next point, you just write down next heading, gear tooth failure. Gear tooth failure. Gear tooth failure. Gear tooth failure. So first of all, I'll explain from my side each and every term, and then we'll write the failure points. Now see here, of course, gear is having a structure. You can see the structure is like that. The profile is toward the top side, it will reduce the thickness, and at the bottom of side, it has having more thickness. It means that it is having root thickness, which is always more. So any kind of the gear or tooth will not break from root. It will break always from addendum part, top side part, correct? So whichever with a smaller thickness, from that point it is going to break. So how it break, what are the reasons behind this failure, so that we are going to learn, and these reasons are applicable to all the teeth, all type of gear teeth, either it may be spur, bevel, worm, helical, applicable to everywhere. So I'll tell you, in case of the gear tooth failure, the basic two criteria of the failure, one is bending failure and second one is a wear failure. Now what is bending? See here, in case of the bending, what happened generally, in case of the bending, you can see this is the structure of teeth on which when force is acting, you can see UDL load is acting in figure B. Load is acting, because of this load, maximum load is acting on the top side due to meshing, so through which the bending will occur. So I can say the gear tooth structure, it has maintained a cantilever beam. Why cantilever? One end is fixed and other is remaining free. So that's why, because of the load, there will be the chances of the bending. Once gear teeth is going to bend, then the formation of the crack over the surface. Second step, formation of crack, and third one be the breakage of the or tooth failure. So these are the three process. So while load applying on a cantilever type of structure as like a teeth, so there will be the bending will occur. So that's why we have written in gear tooth failure, first type is bending failure. It is also called as a breakage failure or breakage of the tooth. So this is the first type which can be occur because of the load applied or at the time of the working condition, at the time of meshing in between engine as well as gear. So these are the things for the failure. First one is a bending failure. Now second, wear failure, or it be called as a surface distraction. Surface distraction. So in case of the surface distraction, what happened? The crack will already form and we'll have to fill up the crack by welding, by adding some material. We'll have to fill up the crack. So that we called as a wear failure. Now you can see under wear failure, they have mentioned various parameters as like pitting, scoring, abrasive wear, corrosive wear, and all that. So what it indicate? It indicate these types of the failures occurs when porosity will occur on the surface of the teeth. So that is wear failure. In short, I would say in case of the bending failure, we can avoid the formation of the crack due to bending. But in wear failure, we cannot avoid. Some porosities remain on the tooth profile. Due to that, failure is occur. It means bending failure can be avoidable, correct? But wear failure we cannot avoid, because once crack is formed, ultimate outcome is after some cycle it is going to break. So that is the basic difference in between bending failure and wear failure. Is that understood?
Yes, sir.
ठीक आहे. तो दोन पार्ट आहेत, त्यामुळे तुम्ही बघताय की बेंडिंग फेल्युअरच्या अंडर कुठलाच क्रायटेरिया दिला नाही. वाय? बिकॉज इट कॅन बी अवॉइड. So bending झालं समजा, so I can with the help of hammer I can straightening the teeth, and again we can reuse, correct? I can again mold it as per the original shape, so we can use it. But in case of wear failure we cannot use. Ultimate outcome of wear failure is breakage. So to avoid that breakage, what kind of the stages are there? So such kind of the stages I'll explain one by one. First one is called as a pitting failure. So now pitting means what? So pitting is nothing but surface failure occur due to porosity or due to maximum bending. The formation of the crack over the surface is called as a pitting failure. Again, pitting failure can be divided into two parts. One is initial pitting, second one is a destructive pitting. Now, what is initial pitting? Initial pitting means small amount of the crack or porosity form on the surface of the teeth that can be adjusted by the welding, or we can remove that crack by using weld, by adding the material, correct? So that is called as the initial pitting. But still crack is or crack mark remains on that teeth. It will going to break after some cycle, but initial pitting helps, we can run as it is, correct? But in case of the destructive pitting means we cannot cover that crack portion by adding the material or by welding. We cannot, it is not possible. So destructive pitting means the maximum amount of crack is formed over the surface and we cannot avoid the cracks formation, and due to that breakage will occur, that we call as a destructive pitting. Is that understood?
Yes, sir.
So one by one we'll write. So before starting the things, one by one, fitting झालं की मी फिटिंगचं explanation देईल. Scoringच्या case मध्ये that explanation from my side I'll give, and then you can write. So right now I have explained thoroughly related to the bending and wear. So before starting the explanation in a point format, you will have to draw this block diagram. Block diagram, gear tooth failure. In case gear tooth failure, you can write left side block diagram, bending or breakage failure, and in case of right side you can write wear or destruction, destructive failure or surface destruction. And that destruction you can divide it into, write down one by one. That is fitting failure, fitting divided into two parts, initial fitting, destructive fitting. Then scoring failure, third abrasive wear, fourth corrosive wear. Corrosive wear. I hope you have drawn this. So first write down bending failure or breakage failure. Bending or breakage failure. So in that first point write down every gear tooth act like a cantilever beam. Every gear tooth act like a cantilever beam. How cantilever? I have shown you the diagram. A cantilever beam which is subjected to repetitive bending stress. It means continuous repetitive bending stress. Due to this gear tooth may break. Correct, this was the first point. Let's check the second point. Due to continuous load, there might be chances of formation of crack, and hence gear tooth breaks away, and hence gear tooth breaks away. Correct. So it can be break. Next point in that you can write this type of failure. This type of failure. This type of failure can be avoided. Can be avoided by adjusting parameters like write down module comma face width in the design. Correct. So this is for bending. Second point, wear failure or surface destruction. Wear failure or surface destruction. In that, write down this type of failure indicates removal of complete layer of the surface or formation of cracks over the surface, which causes surface distraction, Clear? So in case of wear, we have divided pitting. So in pitting, you can write, in case of the pitting, you write down, it is a surface fatigue failure. It is a surface fatigue failure due to repetitive contact stress. At the time of machining, contact will occur. So due to repetitive contact stress. Correct. The pitting can be divided into first write down initial pitting. That's oblique kara. It is also called as corrective pitting. We can correct it. Corrective pitting. In that, write down small pits are formed. Small pits, porosity are formed over the surface. Okay. So below that, next point, write down in that initial pitting. Due to this, errors will occur on a tooth profile. आता एरर कशी येणार बघा. when tooth profile is there and crack is formed, so due to that crack some distance is increased, gap rana na, so due to that some distance is increased. And as we know, the gear can manufactured by the hobbing process or honing process or shaping process. So at the time of machining it has maintained the height as like one module or 1.185 module, we have seen addendum and dedendum. If the crack is formed, that height of that particular teeth is going to increase, and again due to that proper meshing will not be occur, and due to that sudden breakage will occur in the teeth. That's why we have written error in the tooth profile. Correct. So this is about the initial fitting. In that you can write it can be minimized by, it can be minimized by precise machining, precise machining, comma, adjusting the alignment between the gear pair, adjusting the alignment between the gear pair. Correct. And by adding the material in a crack, and by adding the material in a crack. Clear? So this will be about initial fitting. Next, destructive fitting. Destructive fitting. It will form destructive fitting. It will form due to repetitive contact stresses. Repetitive contact stresses. Next point, when load is acting, load is acting, gear tooth exceeds, gear tooth exceeds endurance strength, endurance strength, due to which nature of formation of crack, due to which nature of formation of crack over the surface is increased, is increased. Such kind of failure, such kind of failure cannot be minimized. Correct. इथपर्यंत आपण आलेलो. Now I'll explain about the scoring. The scoring is nothing but it is a insufficient lubricant applied at the time of meshing. So it means that if lubricant is not proper viscous and we have used that lubricant, then there will be the chances of the friction, temperature rise, and through which the formation of the crack over the surface. Therefore, the material lubrication should be highly viscous. Lubricant should be there. In the case of the scoring, if we have not used the lubricant, in that case, the gear teeth form a crack over the surface. Correct. So, in case of the gearboxes, generally gearboxes are closed with the help of casing. So, in that, we'll have to maintain the proper arrangement of the lubricant. If not, there is no ventilation, and due to that the friction and formation of the temperature rise will occur, and that hampers the gear teeth. So that is called as a scoring. So next, write down second your third जे काय असेल तुमचं scoring. In that you can write insufficient lubricant insufficient lubricant used at the time of working of gears, at the time of working of gears, creates scoring effect, creates scoring effect. त्यालाच दुसरं नाव आहे, ऑब्लिक करा, गॅलिंग, GALLING, गॅलिंग, और त्याला तिसरं नाव आहे स्कफिंग, SCUFFING, scuffing, because of insufficient lubricant the gears are worked. So due to that insufficient, what will happen? See here, due to dryness, temperature is going to increase at the time of meshing. So one teeth of gear and teeth pinion mesh at the time of meshing, there will be the temperature rise, and at that time phenomena will occur. Means while gear pair or while gear is touching the teeth of the pinion, so it will remove the material of another surface or pinion surface, and then moving toward the meshing, again another cycle, and it will stick there, again remove, again stick. So this is for every teeth. So due to that, this stick slip phenomena will form the number of cracks over the surface of the teeth. Due to that, failure is occur. All this process will say this is called as scoring, galling, or scuffing. हे कळालं का रे?
Yes, sir.
Okay, just write down. In case of scoring, we have written insufficient and all that. So just write down here. Stick slip phenomena. Stick slip phenomena occurs at the time of meshing. At the time of meshing between teeth of gear as well as teeth of pinion. How to avoid this? By using proper viscous lubricant. That's it. This is about the scoring. Third, abrasive wear. Abrasive wear. So first listen, what will happen? See, in case of abrasive wear, what happened? If some material or some porosity or some crack will occur over the surface, some particle as like a dust particle or porosity or crack removal material, if it is trapped in between meshing, if it is trapped in between the meshing, there will be the formation of abrasion. So due to that, breakage of the material will occur. So the material which can be trapped in between the gear teeth as like dust, rust, weld spatter, correct, metal debris at the time of stick slip phenomena, whatever be the generation generated, that can be leads to fail abrasive wear, correct. So have you understood this abrasion? समझ लो करे. Very simple phenomena are there and theoretical parts. Have you understood?
Yes, sir.
Yes, sir.
Okay, just write down abrasive wear under that title. It is a damage. It is a damage or surface injury. It is the damage or surface injury caused by particles trapped between particles trapped between the mating teeth, between mating teeth, as like, write down, dust, comma, dirt, comma, rust, comma, weld spatter, enters.
Sir, which pattern?
Weld spatter, वेल्डिंगचे तुकडे, weld spatter, SPATTER, weld spatter enters between tooth surface, correct. So again, the solution for this, we'll have to use a highly viscous lubricant so that these kind of the weld spatters, dust, dirt particle can remove by using lubrication. Clear? So that's why if we are using this lubricant properly with proper viscosity, we can avoid the two types of the failure as like scoring and abrasion. Last, corrosive wear, corrosion. So corrosion, of course, corrosion means what? It is a chemical process. It is the reaction in between atmospheric oxygen, and at the time of meshing temperature, that temperature creates the chemical reaction and that leads to corrosion. Correct? So because of this, the formation of the protective layer, if we are using the lubricant, there will be the formation of the protective layer in between the surface, and that leads to smooth operation in between the gear tip profile. But if we are using the temperature range, or if we are considering the chemical reaction in between atmosphere as well as the working condition, in that case the corrosion will occur, and that surface over the gear pair is removed. So removal of the surface will occur. Due to that, corrosion will occur on a surface of the teeth. So just write down corrosive wear. It caused by chemical reaction between lubricant temperature and atmospheric O2, oxygen, atmospheric O2, which remove protective layer between the gear pair, correct, and corrosion will occur, and corrosion will occur. How it can be removed? Again, by using lubrication, proper lubrication, correct. So these type of the failures will occur in gear teeth failure. Of course, if the gear teeth are going for wear failure, after some cycle they definitely going to break. But if it is in bending failure criteria, we can avoid them from breaking, correct. So we can take a precaution, preventive action to avoid the failure. So these are the two parts. So according to these two parts, bending and breakage, we are going to design the things as like bending and wear failure in future, correct. So this is the theoretical question they will ask. Write a note on. You can draw the block diagram and all that with proper explanation. In addition to that, another diagram I have added over here, which include major wear and minor wear. So you can write this major and minor wear also as additional information. Basically, previous जे होते ते basic failures आहेत. या ज्या वियर्स आहेत you can write for your understanding or for additional answer if they have asked for 8 marks, so you can add it. So write down wear. Major wears are adhesive, abrasive, surface fatigue failure, corrosive, same as that at previous. In case of minor wear, minor wear we can prevent to avoid at rattling, solid erosion, fluid erosion, percussion. So these are the methods you can read in a Google, or you will get the process on a YouTube. In case of minor wear, our focus is major wear. So this is for just additional information. And this is the details of gear tooth failure. And these details are applicable for all the gears. Suppose they have asked gear tooth failure for worm gear, so same answer. Gear tooth failure for spur gear, same answer. Always remember. Is that understood?
Yes, sir.
Okay. Okay, over.
Yes, sir.
Next, again, this is again theoretical point. Just write down gear materials. Gear materials. This point till date, since syllabus is designed, they have not asked, but we must know. Gear materials. Write down the title gear materials. Now I'll tell you what is the role of gear material. Before starting any design of the gear, we'll have to select the material first. It is not like that we'll have to design first and then material selection. No, again the properties are going to change, and the whatever with the properties is like hardness, tensile strength, that depends on the material, so that the material selection is the only first step of any gear pair design. So the role of material is to define the properties like hardness and ultimate tensile strength. As I told you, the material is basic materials are two, as like ductile, brittle. Ductile means generally it is steel, composites, alloys are there, which gives the indication before breaking. That we called as a ductile. In case of the brittle, it will not give the indication. They will directly break. That we called as a brittle. Now, so we'll see the various type of the material can be used by the gear pair. As in previous session also I told you, the perfect arrangement in between gear pair is the pinion, which is the smaller one, which always made up of steel, and the gear, which is bigger one, made up of cast iron. That combination is always valid. Many times in case of the low load condition or in case of the toys, the material of gear pair is pinion and gear, both are made up of cast iron, or else both are made up of steel. Correct? So we'll see one by one what are the materials. So firstly, just write down cast iron. Cast iron. The material is we have to consider cast iron. So in case of the cast iron, sorry, cast iron rub करा basically हा पहिला material का लागतं ते. So write down the material is used for gears the material is used for gears denotes the strength and service condition. The strength and service condition. Below that, following are the properties of gear material. Following are the properties of gear materials. First, when gear tooth subjected when gear tooth subjected to fluctuation of load or fluctuating load it should have high endurance strength. मला आठवत असेल SE KA KB KC KD, that was high endurance strength. High endurance strength. Second, it should have low coefficient of friction. Okay, sorry. It should have low coefficient of friction. Of course, because of low coefficient of friction, less amount of temperature will generate in between the structure, and the stick slip phenomena will avoid. So likewise, so low coefficient of friction. Next, it should have low and consistent thermal distortion. It should have low and consistent thermal distortion. Thermal distortion. So these are the basic properties of the gear material selection. So below that, types of the gear materials. Types of the gear materials. In that, first write down cast iron. Cast iron. So below that, write down what is the purpose of cast iron. Gear of larger size. Write down below that. The gears of larger size. Gears of larger size and complicated shapes. And complicated shapes can be easily manufactured by cast iron. So below that, see, these are the cast irons. FG, gray cast iron, 200 is nothing but SUT, and its hardness range is given. Correct. All these things are given in design data book, but if they have asked about write a note on, you will have to write two of them. Malleable cast iron, MCI, grade A. That is again range is SUT and hardness is given. तर या सगळ्या गोष्टी लिहायच्या नाहीत. ग्रे कास्ट आयनचे दोन एक्झाम्पल लिहा व्यवस्थित 3 कॉलम मध्ये. मॅलेबलचे 2 लिहा आणि पुढे एक आहेत नॉड्युलर ग्रे कास्ट आयन आहे तो एक आहे तो एक लिहा. सो जस्ट राईट डाऊन एक्झाम्पल म्हणा. मेक अ 4 कॉलम्स. सिरियल नंबर, कास्ट आयन, टाइप ऑफ कास्ट आयन, SUT, PHL. gray cast iron FG200. FG260. You can write accordingly. Then malleable cast iron. Write two examples for understanding. कारण एक्झाम मध्ये न्यूमेरिकल्सला ते डायरेक्ट देतात FG200. मग ते काय आहे ते आपल्याला कळत नाही. त्याच्यावर इंडिकेट होतं की बाबा SUT आता 200 आहे. ठीक आहे, आणि हे कास्ट आयर्न आहे. So malleable cast iron with grade A and B. झालं का रे?
Yes, sir.
Now next is nodular. I think I have deleted that side. ठीक आहे, examples कळाले. So below that, advantages of cast iron. पटपटले आहे, theoretical आहे सगळं, कुठल्याही बुक मध्ये अवेलेबल होतं. So advantage, first write down. Can create complicated shapes. Can create complicated shapes. Second, excellent machinability. Cast iron have excellent machinability. Third, high compressive strength. मोल्ड करूनच बनवलेले असतात म्हणून कॉम्प्रेशन जास्त आहे. हाय कॉम्प्रेसिव्ह स्ट्रेंथ. नेक्स्ट, हाय हार्डनेस. Limitations. First, due to brittle structure. It includes properties like toughness, stiffness, which create poor effect. ठीक आहे, लिमिटेशन घ्या. सॉरी, लिमिटेशन हे झालं पहिलं. दुसरं लिहा, लो बेंडिंग स्ट्रेंथ. लो बेंडिंग स्ट्रेंथ. Second, steel. In that, write down, it can use from low carbon steel to high carbon steel range. म्हणजे Fe3 डायग्रामचे सगळे लो कार्बन स्टील टू हाय कार्बन स्टील. करेक्ट. सो दीज आर द एक्झाम्पल्स. आपण मागच्या वेळी पण बघितले DME1 ला 40C8, 45C8 and all that. These are the indications. तर याच्यातले एक 3 एक्झाम्पल लिहा. SUT हार्डनेस. सेकंड कॉलम लिहिला नाही तरी चालेल, काय प्रॉब्लेम नाही. द मटेरियल इंडिकेशन, त्याला SUT असतो, हार्डनेस असतो, हे याच्यातनं कळते. आणि कार्बन पर्सेंटेज मॅटर करतं. काय मॅटर करतं? स्ट्रेंथ वाढवतं. देअरफॉर you will get the value of carbon always while indicating the steel 40C8, or you can see If there is a chromium also following the ductility. So you can see the composites 30 Ni nickel, 4 Cr, chromium 1. This will be the indication. कुठले 3 एक्झाम्पल लिहा. ऑफकोर्स एक्झामिनेशन मध्ये हे दिलेलं असतं. आणि SUT SYT जे काय आहे तो स्टँडर्ड प्रमाणे आपण घेतो ते काय पाठ करत बसायचं नाही. झालं का रे?
Yes, sir.
ओके. ऍडव्हान्टेज लिहा. आपण हा मटेरियलचा पार्ट संपू आणि थांबू बरं का. एक 5 मिनिटं लागतील. So advantage write down for the steel. First advantage म्हणा. First high bending strength. High bending strength and surface strength. High bending strength and surface strength. पहिलं. Second, due to ductile nature. Due to ductile nature. Toughness, stiffness. Properties are very good. Toughness, stiffness properties are very good. And third, higher load carrying capacity. Higher load carrying capacity. Limitation. Creates more noise. Creates more noise. First, creates more noise. Second, poor damping property. Poor damping property. And third, more expensive. More expensive. Chalo, next, non-ferrous metal. Non-ferrous metal. ते पण वापरतात आपण गिअरला. कॉपर आहे, अल्युमिनियम, झिंक, टीन, मॅंगनीज एक्सेट्रा. अलॉयज आहेत. Features I have written: low coefficient of friction, resistance to the corrosion and gear, and ability to cast complicated shapes. You can write as it is in from the slide. Third point, non-ferrous metal. Non-ferrous metal. Non-ferrous. Aluminum, iron is not included. झालं का रे? Or
Yes, sir.
last is sintered metals. टॉयज, वॉशिंग मशीन या ज्या डिव्हाइसेस मध्ये ज्या काही गिअर लागतात त्याचं मटेरियल असतं सिंटर्ड. सो पावडर मेटलॉजिकल प्रोसेस असते. यू कॅन राईट आयर्न अँड कॉपर. इट इज हॅव्हिंग लो कॉस्ट and application I have written over there. You can just write down sintered metals. So these are the four types of the materials which we can use for the gear. While doing the project in case of the gearbox, we'll have to select out of these four material for gear pair, either for pinion as well as a gear. Tala?
Yes, sir.
Okay. Today's session, in that we have seen the basic things as like gear tooth failure, which is common to all the type of gears. Then we have seen the material. So do revise the things. Clear? So we'll stop here. Thank you.